Hello everyone, and welcome to today's session for the new combustion analyzer. My name is Primož Gorenček, and I'll present you the latest development done for the combustion analyzer. Those of you that use Dewesoft know that this is not a new function inside Dewesoft. It actually exists from earlier versions, but we have now done complete rework of the module. We have basically made a new module inside the software, which has a new, cleaner, nicer user interface. And we have added some additional functionality, which goes more in line with testing modern combustion engines. So I'll present to you first some theory for combustion analyzer, what are the requirements to run it inside Dewesoft, what you need to be careful with selecting and connecting analog inputs, what are some of the new features, some new outputs that we have also added to the combustion analyzer, how you can transmit combustion analysis data to other systems, and how easy it is to combine combustion analyzer with other modules. Then we will switch to the software, see how this looks like in Dewesoft. And at the end, we'll have a few minutes left for discussion and questions. So combustion analyzer actually measures pressure inside the cylinder, which is a result of the linear movement of the piston to angle of rotation on the crankshaft. What makes combustion analyzer different from any other module inside Dewesoft is that in Dewesoft, we usually measure everything in time domain and also do analysis in time domain. With combustion analyzer, we do the measurement in time domain, but we then recalculate all the data in angle domain and also do the analysis in angle domain. The biggest benefit of Dewesoft is that we still have the data in time domain, which means that we can use that data or signals for vibration analysis, sound or noise analysis, and it makes it a really powerful and universal tool. So the primary use of combustion analyzer is basically in any type of engines, from smallest chainsaws, lawnmowers, to motorbikes, cars, trucks, planes, ships, and huge stationary engines. Basically, we need it whenever we are developing a new engine, testing it in the final phase, we want to fine-tune it, or we need to see what is happening inside the engine, and we want to measure some signal and have the information, what is the value or how does it look like at every position of the crankshaft. In order to run the combustion analyzer, a minimum of 2 sensors are required. One is for the angle measurement and the second for the in-cylinder pressure measurement. In Dewesoft, we support different angle sensor types, either analog or digital, that can be connected to our instruments. For the angle sensor, we need one reference signal per revolution with any kind of sensor type. And we support an encoder with 1 line or 2 lines, which are shifted for 90 degrees with 1 0 pulse. It's also possible to use a gear tooth sensor, which has a missing or double teeth and is our reference point. These sensors are usually found on engines as stock sensors or OEM sensors, and we can basically just tap into the signal and use the existing sensor on the engine. So we don't have to do any modification, install additional sensors, which just take a lot of time and money, and it's not always possible to install a separate sensor because of the limited space inside the vehicle. A commonly used sensor is also CDM with 0 pulse. This is basically a disc with even pulses and 1 0 pulse. Or as a last resort, it's also possible to use a tacho sensor, either analog or digital, which has only 1 pulse per crankshaft revolution. The problem with that one is that since we have only 1 pulse per revolution, we then use interpolation between 1 revolution and the second, and we assume that we had constant rotation in between, which is not always the case with an engine, so we don't have such high accuracy results as with other sensors. For the pressure sensor, we support direct charge type inputs, which mean that any AVL or Kistler pressure sensor can be directly connected to our amplifiers. If you have a pressure sensor with an inline amplifier or an external amplifier, it's also possible to connect just voltage or current inputs to our instruments. And together with those sensors, it's also possible to connect CAN, CAN-FD data, XCP, CCP to get all the data from the ECU directly. And voltage, current, IP, charge, any type of analog inputs can be combined together with video or GPS. And all of these signals can always be perfectly synchronized between each other. And there is no limitation on how many analog inputs can be used at once. One thing that where extreme caution should be made is with setting up the analog filters or the filters for the analog inputs. So for charge type sensors, we can have in some cases some noise, which is a result of the sensor not being mounted flush inside the engine, or we have low cost cabling, which pick up a lot of noise. These two problems should be fixed at the source, but wherever this is not possible, it's also, we can use filters inside Dewesoft, so analog filters on the analog inputs. But we have to be careful. If we take a look at the low pass filter, for example, we recommend a filter above 30 kilohertz. The reason for this is if we use a filter of first order with 1 kilohertz, at 1000 RPM, we will have 4% IMAP error. If we go to 8000 RPM, it will be 14% error. Now with a filter of 30 kilohertz, this error will be negligible. And same goes for high pass filter. This should be below 0.07 hertz. Again, if you go to 1000 RPM, and if we would use a filter with 1 hertz, we would have an IMAP error of 14%. If we would use a filter below 0.1 hertz, this error would be less than 1%. So these filters need to be set up before the measurement, otherwise the results will be incorrect, or there will be huge errors in the results, and the measurements have to be repeated. We can do all the calculations and modifications otherwise offline, but if the analog inputs are measured with wrong filters, then the measurements need to be done again. Some of the new features of the combustion analyzer that was now reworked inside Dewesoft is, as you can see, a new user interface. The settings are now all in one place. So we have settings for the engine. We have a separate tab for the angle sensor settings, and in the end we have all the outputs and settings for the outputs. The firing order is now much simpler and quicker to define. Before we had to input the exact angle of ignition misalignment. Now we just input the number of cylinders and select the firing order from the list, since we have most of the standard engines predefined. But custom firing orders are also possible, and it's still possible to input the exact ignition misalignment if it's some special engine with non-standard angles. A new feature is cylinder deactivation. Here we have an option to deactivate each cylinder separately, and we have an option to just put it permanently to activate it or deactivate it, or we can also select a channel source. For example, an analog channel or a CAN channel can be a source of information for switching on and off a cylinder. And for example, we can use a CAN channel, get the information from the ECU when a cylinder is active or not, and Dewesoft will then switch it on and off automatically. and that's the deactivated cylinder will then not be used for mean value calculations. This can also be used if one of the sensors fail. For example, if we have an engine with 8 sensors and 8 cylinders, otherwise we would have to modify the setup and remove that cylinder so it's not used for average value calculations. But in this case, we can just switch it to deactivated and it won't be used. A new feature is also zero level correction setup. We have all the standard correction principles as before. So no correction, thermodynamic correction, correction from a fixed value or from a measured value. For example, intake pressure sensor for a turbocharged engine. And we can now define the zero level correction for each cylinder separately, which is useful if you have mixed pressure sensor inputs. So for example, using charge type sensors with thermodynamic zero level correction and using sensors which have built-in zero level correction and voltage output. And in that case, we would just switch those cylinders to no zero level correction. A new development was done so that we can now input 2 polytropic coefficients instead of 1. So we have one polytropic coefficient which is used only for compression phase, and we have a second polytropic coefficient which is used for the combustion or expansion phase. And it's also possible to get the polytropic coefficient as an output. So it means that Dewesoft can automatically calculate what the polytropic coefficient is. And we can also override the manual coefficient and use the calculated polytropic coefficient automatically. One new feature is variable compression ratio. So this was done for engines where the compression ratio is changing during the operation of the engine. And we can actually use variable cylinder volume. Normally, we would define the volume from geometry, which would then be fixed. Now it's also possible to import a text file with different volume curves or define the volume from a template. If we have volume from a file, we can just load the curve, select if you want to use a variable curve or if we want to use just a fixed curve from any of the curves that are in the file. And same as with cylinder deactivation, we can also select here a channel source, which can again be a CAN channel, analog input, math channel, and Dewesoft will then be able to automatically switch between different volume curves or different compression ratios depending on the information that we get from the ECU. And the switch can be done at the start of each new cycle. We now also have higher accuracy recalculation inside Dewesoft. So the range is from 2 degrees to 0.025 degrees. And offline recalculation is possible. This means that we can capture all the data with 2 degrees or 1 degree angle resolution. And if we see that we need higher accuracy, we can then do offline recalculation and use higher accuracy. Now also batch recalculation is possible for the combustion analyzer if we do any modifications of the setup. It is possible to use multiple combustion analyzers. So we have an unlimited number of combustion analyzer instances available. One of the use cases for this would be, for example, if you would do combustion analysis on a compressor, where we would have different sizes of the cylinders, we would just use combustion analyzer 1 for the first cylinder to define the geometry with the geometrical information, bore, stroke, connecting rod, compression ratio, and so on. And we would use the second combustion analyzer for the second cylinder. This way, we don't have to use special volume curve files or for templates. We can just simply use 2 combustion analyzers and then add the results of the combustion analyzers together. We have new standard outputs available. So one of them is the compression curve. We can now plot and calculate the theoretical compression curve from the combustion analyzer. Like I mentioned, we can calculate the polytropic coefficient. And together with thermodynamics 1 calculation, we now also support thermodynamics 2, which gives a better approximation of the results for rate of heat release, accumulated heat release, mean mass fraction of fuel that is being burnt. We have now all the settings in a single tab, so all the results are grouped together where we can just switch between them and set them up. And we have statistic results available for every output. So every output has the current value output. We have the running average, which is defined by the number of cycles we want to look at. Then we have the overall average, which is the running average for the complete engine. Then we have the cylinder average outputs, which is the average result for the complete measurement of each cylinder separately. And we have also engine average, which is the current value of all cylinders combined. So an average current value of all cylinders. Combustion data can also be transmitted via CAN. So on every DW43, you have 2 CAN ports, which can be used for receiving or transmitting CAN data. Or if you have one serious slice, you also have one CAN port on the backside of the instrument, and you can use that to transmit CAN messages. So we just create a new message, add a channel, define on which event we want to send it out, either periodically or on some changes or triggers. Select our channel that we'll be sending out, for example, maximum pressure, define the scaling, and that's it. We just create a few messages, and in a few channels, we export the DBC, and we can import that DBC onto the host system, and immediately we'll be able to get data on the host system. So this is one option. The second one used on dynos is a Testbed plugin. So we have a dedicated Testbed plugin for sending the data to the Testbed control center, and also for having the possibility of controlling Dewesoft from the Testbed control center. Together with the rework of the complete combustion analyzer, we have also remade the Testbed plugin. So there's a new interface, some new features. It's now possible to import and export the channel list, set which channels are sent out. We can send out cycle-based data or even switch to time-based data so that we can define over how many seconds we would like to store and calculate the average results. So this can be useful if you want to have power module together with combustion analysis for hybrid engine analysis, and we want to send out mostly power data. So we support the standard AK protocol, Puma Open, D2T, Tornado, all of them, or on RS-232 or TCP IP connection. Combustion analyzer can be very nicely coupled with other modules inside Dewesoft, for example, with the power module, and we have a really good hybrid engine analyzer, which is one of the most portable hardwares on the market. We can do torsional vibration for engine shaft rotational analysis together with combustion analyzer. We can do order tracking for vibration analysis, or we can add sound power and do noise analysis. We can also synchronize high-speed video with the combustion analyzer and actually measure the pressure, synchronize it perfectly with the video to see what is happening inside the engine at every degree crank angle. Now we'll switch over to Dewesoft, and we can see how the new combustion analyzer looks like. For this demo, I'll be using the file replay option. So I am just replaying over some pre-recorded analog data. Let's first just enable all the inputs. and go to measurements so that we see which kind of signals we have. So just zoom in a bit. And in the first channel, we see some angle sensor signal, and then we have 8 pressure signals. So this is an 8-cylinder engine with a 60-2 angle sensor. Now we will just define all the analog inputs so we can change the name. So these are pressures. This is the 60-2 angle sensor. We can also change this to pressure, and we have bar. We can quickly change the scaling, and we are basically done. If we would have actual inputs, we would input the sensitivity of the sensor. We would check if the filters are set correctly, and we could immediately start measuring. Now let's add the combustion engine analysis module. So we immediately get a message that a reference pressure channel is missing. So we need to first assign the pressure channels. We'll just switch it to 8 cylinders. We select the pressure channels, and you can see that as I input the channels, also the color of each cylinder is changing. And this is actually linked to the color that is predefined for the analog inputs. So the colors are transferred from the analog inputs, also the scaling is transferred, and all the cylinders will have the same color for all the outputs here. So we can just change the color in the setup, and we will have the same color for all the outputs for that cylinder. We can also input the firing order. For that, we need to see what the firing order actually is. So if we zoom in a bit, and if we start with the first cylinder, so the first one is cylinder number 1, then we have 5, 4, 8. So 1, 5, 4, 8. Then we have cylinder number 6 and 3. And we can find the firing order from the list. So we have 1, 5, 4, 8, 6, 3, 7, 2. And we automatically get the ignition misalignment, or we can also just manually type it in if that is needed. Now for every cylinder, we can select also the deactivation source and so on. But let's first just complete the setup. So we see that the trigger channel is not selected. We'll just go to encoder settings, select our sensor from the list. So the 60-2 is the standard sensor, which is already predefined, and we can select it, or we can just add our new sensor, and we select the input that it's connected to. Here we'll just change the trigger offset to 80 degrees to get the correct misalignment of the sensor, of the angle sensor and the pressure sensor. And immediately we have a live preview of the pressure volume diagram of the actual pressure in angle domain. And if we go to measurement, we will have a new measurement screen already enabled where we can see pressure in the time domain. And we also see pressure in the angle domain. Now we can add all the pressure channels to see if they are perfectly aligned, or if we had some misalignment, or if we had wrong misalignment. So we see they're nice on top of each other. And I'll just remove all of them for better visualization of other results. Here we have also the pressure volume diagram, and we can add other outputs on the numerical displays. So let's go back to see some of the other options. So for every cylinder separately, we can now define the activation source, if the cylinder is activated or not. We can define the correction principle, which can be thermodynamic, fixed value, measured value, or no thermodynamic correction principle. We can also add additional channels to each cylinder. So this can be useful for measuring fuel pressure. And if you want to relate that fuel pressure to a certain cylinder, you can just add it as an additional channel. It will then be recalculated into the angle domain and shifted for the misalignment that we have specified. We also have ignition and injection detection, so we can assign an injection or ignition analog channel, define what is our trigger level and how many of these events we have, and Dewesoft will automatically calculate at what angle is the start of ignition or injection and at what angle is the end of ignition or injection. And if we have 10 of these events, we will get 10 starts of ignition and 10 ends of ignition. In the encoder settings, we can change different resolution for the calculation of the results. So if we need to have higher angle accuracy, we can change to higher angle resolution, but this will produce much more data at the end. So if it's not needed, we can stay with lower angle resolution. And at the last step, we have all the outputs. We always have pressure and additional channels. So additional are the channels that we define together with each cylinder output. And we can define the running average for all of these results. If you would want to see running average values for the pressure channel, we can also enable maximum pressure calculation, which gives us the actual maximum pressure of each cycle and the angle at which we have maximum pressure. Then we have compression curve plotting, and we can define at which angle we have the reference. So for example, if we enable the compression curve, we can just add it to the graph. And this is our theoretical compression curve without combustion. We can also add, for example, maximum pressure outputs. So what is the maximum pressure output of first cylinder? What is the position of the maximum pressure? We can also enable calculation for the polytropic coefficient, and we can even override manual coefficient so that we don't have to input these values. We can actually use them from the calculation. So in this case, they're grayed out and used directly from the calculation. We also have derivative calculation of the curve, of the IMAPs, work, power, torque, thermodynamics calculation 1 and 2, temperature, and knocking based on the -1 video algorithm. So all of the outputs are available just with a click of a button. If we need some average outputs, we can just select them. So as you see, you don't need to make any complicated formulas or analysis. You can just enable additional outputs and immediately you have them on the list and you can use them in the measurement. So the combustion analyzer has gotten even simpler to use, faster to use, more intuitive, and we have now really, really powerful outputs for doing analysis on any kind of modern engine. As you see, we have support for all sensor types available: charge, analog, voltage, or current. The software is done to be extremely easy to use and intuitive, and we have one of the smallest and most flexible hardware packages on the market. So together with sending out CAN data and the Testbed plugin, we have perfect integration for any test system, and we can synchronize acquisition of multiple sources at once. Combustion Analyzer is also available online as part of the pro training tutorials, and we also have an extensive manual where more information is available. So I thank you for your attention, for attending the webinar. And if you have any questions, you can direct them to the emails. Now, if you have